This is the end of section 6.1. This is some homework examples. So in this problem, you're supposed to match the polynomial function with this graph. Okay, so I'm looking at this. I see odd degree. Alright, and remember, odd degree will do one of two things. It'll start up and then go down, or it'll start from below and make its way up. Alright, it'll do this, start above and go down if it's a negative leading coefficient. It'll do this, start below and make its way up, or fall left, rise right if it has a positive leading coefficient. Okay, this one has a negative leading coefficient, so it's going to do this. Alright, and the only one that does that is choice D. Okay, so this is our answer. Alright, don't forget you can just graph that on your calculator to help you as well. Alright, here's another one that says use the given graph. Here's the graph of this polynomial. Answer these questions. So estimate the x-intercepts. So there's an x-intercept, there's one, and there's one. So it looks like we got negative 2, 0, alright, 2, 0, and 4, 0. Alright, stay where the leading coefficient is positive or negative. Okay, so this is going up, this is going down. They disagree, so this one rises right, falls left, so that means we have odd degree. Alright, and remember, odd degree, if it rises to the right and falls to the left like this one does, then that means we have a positive leading coefficient. Alright, and then part C says determine whether the polynomial function is cubic or quartic. It's cubic because it has to be an odd degree. So 3 is a cubic, 4 is a quartic, so it has to be a cubic. Alright, also it bends 2 times, so that's another giveaway that it's a cubic. Remember, the number of bends, the number of turns, is 1 less than the degree. So that's 2, so the degree must have been 3. Alright, and then here at the end, use that equation. It's a polynomial, right? But it is written in a factored form, meaning instead of writing it out completely, we've got it factored this way. So state the degree in the leading coefficient. This is actually because x times x squared, if we multiply this out, we get an x cubed. So this is actually degree 3. So this is a cubic. Okay, now how do I know that? Another way to know that, this is in a parentheses, this is in a parentheses. Take the exponents on the x's in those parentheses. Okay, if there were anything out here, you would multiply. Like if there were, like, hypothetically, let's say there were a 4 outside those parentheses, I'd multiply the x times the 4 and I'd have a 4. If this had been a 3, I'd multiply 2 times the 3 and I'd have a 6. But anyway, you take whatever's in the parentheses on the x and multiply by what's out on the outside of the parentheses on the x. Alright, and here in this case it's 1 both times. Alright, and then you add those two things together. So this is just an x to the first, alright, and an x squared. So I take the 1 and I add the 2 and I get 3. Okay, so this is a degree 3 polynomial. Alright, describe the end behavior of the graph of the function. Oh, sorry, I forgot to do this part. And the leading coefficient. There's nothing out here being factored out of this thing, so the leading coefficient is 1. Okay, so a positive 1, odd degree, describe the end behavior. So for part B, it falls left and it rises right. Now using the wording that this book would use, it would say opens down on the left. opens up on the right. Alright, so either one of those, this is fine like for a test where you're having to do it. For me, for your homework, you may need to use this opens up and down wording. Alright, and then part C, support your answer by graphing the function. So for part C, I'm going to cheat a little bit and throw it in my calculator. Alright, I've got it in my calculator. I'm going to hit zoom 6 to get back in the standard window. Alright, and what did I say it's going to do? Fall to the left. So it falls to the left, rises to the right, rises to the right. So this is exactly what we said we're going to get there. Alright, so nothing like a graph to help make your argument for you when you're doing something like this. Alright, so this one falls left, it rises to the right.